Hello YouTubers, welcome back my friends. In this video I'm gonna show you my PEMF setup here. This is 410 volt PEMF circuit that I've been working for a while on. It's based off of this circuit here, which is a basic PEMF 1B circuit. You can find it on my website. If you go to bbmpulsar.org and go to electronic circuits, you can find this circuit under that page there. So what it consists of, a few components. Okay, let's start with the motherboard. Right here is the whole motherboard for this PEMF device. Look at it from this side. Right here is the MOSFET for channel A. On the other side I have a MOSFET for channel B. I have two filters, one for line in, another one for built-in frequency generator. This filter limits maximum allowed frequency, which is 600 Hz at this setup here. Then I have optocouplers down there. I have a digital filter right here, and I have two diodes, each diode for each channel. It's a reverse spike blocking diodes here. Then I have two channels, channel A and channel B. Unfortunately, I do not have two coils at the moment. I only have one coil to test with, and I will perform tests using one coil only here. This is a capacitor bank for channel A. This is a capacitor bank for channel B. Right here is the power board. As you can see down below, I have two transformers. Each transformer is 300 watt and has two primary and three secondary windings. Last winding I had to wind it myself to make this to have different power levels. So the last winding, which is this top one, is made out of 14 gauge wire, and it outputs about 60 volts. And what these relays are here, if you've noticed, they're kind of in groups. So these four relays here work with this transformer for channel A, and this group of four relays works with this transformer for channel B. These two relays are power relays. They control main power to the transformers. So I can control it with small switch and turn them on and off. Okay, also right here I have a diode bridge for channel B, and here is the diode bridge for channel A on this side. I haven't mounted yet to the plate, so I can show you the back side of it. I know that's my first prototype. Next ones will look better. So this is the first one that I have designed. Here to the right on the board I have a couple of fuses. These are fuses here, and also this is a current triggering circuit. Anytime I can set up with a variable resistor here. However, If anytime any of the transformers draw more than 600 watt of power, this will trigger and deactivate the signal. Actually, it will mute the signal to the motherboard. And here is the mute wire that comes from here, from into here. All right, next thing I have is the power switch. This power switch has 5 levels of power. Okay, so this is the information on the board, this one here, power board. And so we have a switch, manual switch, which have 5 positions here, with the 6th position being the off position. This is the back side of the board. That's how it looks, with all the pathways. And this is a transformer. So basically it has 2 primary and then 2 secondary, and then I added another 60 volt windings here. And this is the last winding, which is right here, I added. And here are the position. Every time you switch one position, you increasing or decreasing the power by 20%. So first position, you will give you 60 volt, 120 volt, 180, 240, and 300. Remember, when you add capacitors, they will filter out the spikes and raising the voltage another 20 something, close to 30%. So this 300 volt AC, when you convert it to DC and feed it to capacitors, will end up to be around 410, 420 volt DC. So this is a 300 watt transformer that I'm using here. Alright, so the next thing I have is the voltmeter. This is the voltmeter that will measure the voltage into the capacitor bank and will tell me what voltage am I working with. Also, this is a frequency / duty meter. This is a digital meter, and I can switch between duty and frequency here. Also, I have a frequency generator, and I can set between 1 Hertz all the way to 600 Hertz. Also, this is the switch that we have seen it on the paper. I can switch between 60 volts and can go all the way to 300 volt AC, and that will end up to be around 400 volt DC when converted into the DC. Also, to the motherboard, I have a couple more inputs that are currently connected, and what this is this is a built-in built-in frequency generator, and the idea is to have frequency to be set on this chip SD card, and there is 2 frequency here. One frequency 432 Hertz, second frequency 528 Hertz. And also I will have an adjustment here, variable resistor, that will allow me to adjust the duty, and I can go down to 1% on a duty and increase all the way to 20%. Also, I have line in. This is the input from the computer. You can feed your own signal into here. For example, you can feed 12 Hertz 2% signal for 30 seconds, and then you can switch it and feed 120 Hertz with 5%, for example, for however long you want, and then so on. So this is like a program you can feed into and have different frequency come out, whatever you feed it, and it's just gonna be converted into the magnetic energy from this coil. Also, I have a switch right here. This is the input switch. Has 4 positions. Position 1 is all the way to the left, 2, 3, and 4. So first position is gonna be one of these frequencies, most likely 432. Second position is gonna be this frequency, and third position is gonna be frequency generator, and we're gonna play with that, and I'll show you how it works. Also, the last one is your line in. So anytime you switch to the last position, circuit will look for the signal to be fed into the line in. All right, I'm excited. Let's turn it on and see how it works. Are you guys excited? I certainly am. As I said, this circuit is based on this basic circuit here, and pretty much all the parts that is in this circuit, they are used here. This is a slightly complicated version of this circuit, but it's very similar. Also, last thing to mention, this is the power meter. Gives me my input voltage reading, gives me my power draw, gives me my amperage, and gives me my total power consumption over time, so I can monitor a few values with it. Are you guys excited? Let's turn it on. The other side. All right. Let's see. Don't have any voltage in the capacitors right now. Also, I have my Tesla meter here so that we can perform the measurements. Okay. So, this is how the power meter looks like. I'm sorry, frequency generator looks like. This is how the frequency and duty meter looks like. You can switch in between. I'm sorry. You can switch in between duty and frequency. All right. Let's select input number 3, and we can play with some frequencies. Also, I have some metal washers here, and I use this for testing purposes. I would place it on a coil and react with magnetic field, and I can demonstrate somewhat power output. It's not the best demonstration, but I can see the energy, magnetic energy coming out of this coil. Okay, so let's switch to the position 1, which is 60 volt, actually 80 volt, and let's see. So this is the position 1, and will give us 80 volt. This is position 2, will give us 160 volt. Position 3 240 volt, position 4 310 volt, and position 5 is gonna land us around 410 volt. Alright, so capacitors are all the way charged. By the way, this is like a power adjustment. So basically you would adjust your coil driving voltage with this, and so by adjusting it, it works as a power adjustment. Alright, so we have 80 Hertz as a set. Frequency is not being fed into the coil, so it shows zeros. Let's give it a little test here. I'm gonna adjust the duty couple percent, and we have magnetic energy coming out. Increase it a little more so I can demonstrate to you. You can probably hear. Let's increase. So we're pulling 138 watt right here, and if I increase, if you look here, this is your frequency, which is 80 Hertz, and if we switch between, we can have 3.6% duty. And if I go more duty, 4, 6, 7, 8, 9, 10, I will start getting the signal in. So if you look here, this is the voltage from the capacitors. They're charging and discharging, charging, discharging. And here is really intense. It's really strong. Pulls. All right. Alright guys, I want to show you the power test. Have my Tesla meter here. It's set to pick up the highest value in DC. Test will be performed using low frequency. I'm gonna go 1 Hertz and see how much we get. Alright, 1, 2, 3. There we are. Got 1.12 Tesla. That's how much it pulses when it gets to the low. 1.1 Tesla. Let's increase the voltage. Let's increase the frequency to about 10 Hertz. And let's perform measurement at 10 Hertz. So I'll go ahead and reset it. We'll go up to about 20%. In just a second, I'll go ahead and reset that, and let's take a measurements. Here we are. We're getting 1 Tesla, which is 10,000 Gauss, 10,840 Gauss, coming out at 10 Hertz frequency. So let's go ahead and adjust to 100 Hertz. Hertz, and let's perform the test at 100. Reset. I'll go ahead and reset the value here, and let's see how much we can get from 100 Hertz. Alright, I'll go ahead and increase the duty. To about 20%, and let's see. Alright guys, looks like we get 0.368 Tesla at 100 Hertz range. Let me see if I can get a look at 30%, and let's see what we get. At 30% we get 0.518 Tesla. So that's how much power get from at 30% range at 100 Hertz. So the next frequency I'd like to test, I'll go ahead and reset values here, and I will go to 600 Hertz. And we'll test how much I can get at 600 Hertz. So let's go ahead and do it. On increasing duty to about 30%. This is the maximum, and let's see what we get. Here we are. Get 0.407. This is 4070 Gauss. You guys, let me lower this down and put this aside. Alright, so 4070 Gauss. This is going 600 Hertz. Remember, this meter, it doesn't measure average, it measures individual pulse, and calculates individual pulses. So that's what we get. 0.4 Tesla, which is 4070 Gauss, each individual pulse at 600 times a second. That's how much power this coil puts out. It's already getting warm from just me testing it. Of course, at lower power, if I decrease the power, I'm not gonna get so much coming out of it. So what needs to be done with this circuit? I need to redesign the coil. I'd like to have airspace in between these layers here, so I can blow the air and cool it off. So that would be my one task to do. Another thing is I will be testing aluminum as a magnet wire instead of the copper, a little bit thicker, 13 gauge. I have a lot of it, and I'm gonna have to build another one, build two of them to fully use all the power that is being stored in both capacitor banks. Having two coils, you can have your treating spot in between, and if you have north coming out of here and then south coming out of here, you can have push-pull effect. If you have north pushing from this side and also north pushing from this side, you can have push-push effect, and this will be later tested and studied for effectiveness. Also, what I need to do, obviously I need to put everything in a case, encase everything, and put this up front, place this up front, place this up front. This is gonna go in the front face. Power adjustment is gonna go in the front. Also some LEDs and some other controls will go up front, and everything will be fit inside the case. So when it's all complete, I'm gonna show you how it looks, but right now it's in the prototype stage as is, showing you how it is. What do you guys think? I'd like to get some feedback from you. You can leave your comments down below. Subscribe if you haven't done it yet. I have a lot more material to cover, and I'll see you in the next video.